All right, let's jump right in. Today, we're talking about something that connects literally everything. I'm talking about matter, the very stuff our universe is made of. Seriously, think about it for a second. You've got your phone, which is solid, your coffee, a liquid, and the invisible air you're breathing right now. What could they possibly have in common? Well, the answer is actually pretty simple, but it's also kind of profound. They are all made of matter. That's it. Everything you can see, touch, or even feel, it's all just different forms of the same basic stuff. Okay, so saying everything is matter is a great start. But what do we really mean when we say that? What's the official scientific definition? And here it is. This is the classic textbook definition. So, occupies space, that just means it takes up room. It has volume. Has mass, that means it's made of, well, stuff. And can be perceived by the senses, that's just our way of saying we can actually interact with it. We can see it, we can touch it, we can feel it. But here's the thing. That definition doesn't really explain the magic, does it? Like, how can the same basic stuff be a hard phone 1 minute and invisible air the next? To get that, we've got to zoom in. Way in. And once we get down to that tiny, tiny level, we start to see that all matter is playing by the same rulebook. It's this incredible idea called the kinetic molecular theory. So rule number 1, the absolute foundation of it all, everything is made up of these ridiculously tiny particles. We're talking atoms, molecules, ions, you name it. The best way to think about them is like the universe's ultimate set of Legos. And these little Legos, they follow 3 basic rules. First, they are always moving, constantly jiggling around. That's called kinetic energy. Second, there's always space between them. And third, they're always pulling on each other, kind of like tiny magnets. And get this, the constant tug of war between that movement pushing them apart and that attraction pulling them together, that explains pretty much everything. So how does that simple tug of war create the entire world we see around us? Well, it's what gives us the 3 main states of matter we all know and love. This is a great little cheat sheet. It shows you the big differences at a glance. Just look at how things like shape and volume are completely different depending on the state. So let's dig into why, and we'll start with solids and liquids. Okay, check this out. On the left, you've got a solid. Think of those particles like super disciplined soldiers, all locked into a perfect formation. The attraction between them is crazy strong, and they just don't have a lot of energy to move around. Now look at the liquid on the right. This is more like a packed concert. Yeah, the particles are still close and attracted to each other, but they've got enough energy to kind of shove and slide past one another. And that's why solids are, well, solid. That super strong attraction and low energy means they hold their shape and their volume. The particles are packed in so tight, which gives them that high density, and all they can really do is just vibrate in place. Liquids, though, they've got a bit more juice, more kinetic energy, so the attraction is weaker. They stick together enough to have a set volume, but they don't have a fixed shape. They just flow and take the shape of whatever you pour them into, all because those particles are free to roam around. But what happens if you crank the energy way, way up? Well, then you get a gas. And this is a whole different ballgame. It's not a disciplined army, it's not a crowded concert, it's a full-on chaotic mosh pit, where every particle is just flying around on its own. For gases, the particles have so much energy that the attraction between them is basically zero. They are just zipping around randomly at incredible speeds, and they'll spread out to fill any space you give them. And that's exactly why gases have no definite shape, no definite volume, and are super low density. So here's the big takeaway. The only thing that's really different between an ice cube, a puddle of water, and steam is how much energy the particles have. That's it. And that means we can force matter to shapeshift just by adding or taking away energy, usually as heat. And this right here shows you exactly how that works. It's a two-way street, right? Just follow the arrows. You pump in heat, and a solid melts into a liquid. Add more heat, and that liquid vaporizes into a gas. But it works in reverse, too. Pull the heat out, and a gas condenses into a liquid, and that liquid freezes right back into a solid. Let's take melting, for example, and just walk through it. So you start heating up a solid, right? Its little particles absorb all that energy and start vibrating like crazy. They're just shaking and shaking until finally they shake so hard they actually break free from those forces holding them in place. And poof, they start sliding around. The solid has become a liquid. Okay, so whether we're melting ice or boiling water, there's a huge fundamental rule that's always in play. So let's zoom back out from the tiny particles and look at one of the golden rules of the universe. Meet Antoine Lavoisier. This guy, a total genius of a French chemist, came up with an idea back in 1789 that literally became the foundation for all of modern chemistry. And this is it, the law of conservation of mass. What it means is you can't just create matter out of thin air, and you can't make it disappear into nothing either. All you can do is change its form. The amount of stuff you start with is always the exact same amount of stuff you end with. No exceptions. And here's the beautiful, simple proof. This is called Landolt's experiment. He took two different chemicals, sealed them in this H-shaped tube, and weighed it very, very carefully. Then he just tilted it. The chemicals mixed, there was a reaction, things definitely changed inside, but when he weighed it again, the mass was exactly the same, down to the microgram. The stuff changed, but none of it vanished. Just stop and think about that for a second. It means that the total amount of stuff in the entire universe is constant. It never changes. Every single atom in your body, in this planet, in the farthest star you can see, it's all been here since the very beginning, just getting shuffled around and rearranged into new things. Nothing is ever really gone. Which, of course, leaves us with one last mind-bending question. If matter can't be created or destroyed, then where did it all come from in the first place? If you can't make it from nothing, where did all this, the stars, the planets, you and me, where did all this stuff originate? Now that is a question for another day.